Hello everyone, this is James Yu, and this is my live demonstration of my Project 1 Morse Code LED project. So currently I have my screen shared as well as my setup, my Arduino breadboard and LED. Uh, and so first we'll go through the code and then I'll end with live encoding of a string to its Morse code. So first off, we have two integer variables, one for the unit time, which will be used for the length of the dits, the das, the spacing between letters, and the spacing between words, etc. And then I have another one for the output pen, which in this case we're using 13. 13 was useful for initially because it also has a built-in LED light with it. So moving on, we have the character arrays for all the symbols, the letters, the numbers that I wanted to be able to translate to its Morse code. And we have a array of pointers to the Morse encodings, uh, and I put it in a way that's easy to index using its ASCII value. So I also have a error symbol and a pointer just to um, be able to print out a error warning when a character that isn't recognized by the program is entered by the user. Moving on, we have our functions, the dit and the da function, essentially write to the output pin high to make it flash, and then it delays to um, time the flash to a specific length, and then it writes low again to turn off the LED. So what this does is it allows it to control the timing of the flash. That's our 1 unit of time. Da is 3 units of time. And then we have in letter and word for the end of a letter and the end of a word, respectively. They're delays when the output pin is low. The Morse converter function takes the character we're trying to translate to its Morse code, um, and it will spit out the character pointer to its encoding where it's stored in memory. So you can see that it uses a value to index the Morse ASCII array that you saw earlier. And then there's the flash Morse character function, which basically iterates through the encoding the dots and the dashes and calls dits and dot respectively for the dot and the dash respectively. We have print characters, which will take the entire string and then iterate through every character. Calling those two helper functions we went through above, the Morse converter and the flash Morse character. And then we have the setup and the loop functions, which are required. And the setup will basically set up the output pin and set up the serial monitor, as well as the loop. The loop will continue to poll for new input strings by the user, and it'll keep doing that until we get to a sentinel character, which is the pound sign in this case. And if we just input the pound sign by itself, this if statement should cause it to run a delay, which will allow for any other transmission stuff. and then it will exit, which exit essentially puts the processor in an infinite loop such that it's not able to respond to any additional input. So now that we've gone through the code, let's test this out. So in here, I'm going to start off with hello world. And let's see what that is in Morse code. So now it starts flashing. You see it also printing on the monitor. This really helps with readability because the flashes are very tough for me to read. So this is HELLO, and this is WORLD. So we know that hello world has printed. Between each word, I also made it print a new line so it's easier to read. So it looks like that worked. Let's also try some other things like $50. And since I don't exactly have this stored in memory, let's go up to dollar. Listen to this and see what it spits out and see if it matches. So we see dollar, it looks like that matches with the first character, and then 50, which is all dots and then all dashes. So that looks like it worked, which is great. I also added the new line pro sign. So this will basically allow it to print the signal a new line in Morse code, which will be dot dash dot dash. So let's go ahead and send this and see what it outputs. So it looks like that worked. And now let's try the sentinel character to terminate this process. And let's go ahead and set that new line to no line ending. So we'll send this, and a feature that I added is that it will print out the pro sign end of transmission when the pound is entered. So that's what you see here. And it looks like that's all that's printed. Now let's check if it worked by typing in hello world again and seeing if there is any input or output. Sorry. And there's nothing. So it looks like it worked. So this concludes my project 1 demonstration.